In the last video, I gave you a not so good explanation. I don't expect you to fully understand it. In this video, I'm going to give you an example, and hopefully, well, you need to see lots of examples, and then hopefully you will get an idea of what's going on. So back to the example. So here, your enemy is standing here. The enemy is 500 meters away from you. You're going to fire a cannonball. You're going to fire a cannonball 80 meters per second at an angle of 72. The question is, will you be able to hit your enemy? Okay, so just remember that when you fire the cannonball, it will travel in this path here, and the up and down of this cannonball as it travels through is the same as you firing the cannonball vertically upwards, but taking into account the vertical component. So what I mean by that is that when you get given this here, well the diagonal is quite difficult to understand what's going on. So you break up this diagonal into the vertical component and the horizontal component. So when you have something that's at an angle, let's say let's say you fire something at an angle of speed of 80 at an angle of 72. Use your trigonometry to work out you see this vertical component here is the same as this length here. So use trigonometry. So this here would be a sine. So this here would be 80 sine 72. Okay, and then this this distance here would be 80 cos 72. So here the up and down of this thing, you can visualize, well, you can pretend that you're firing the cannonball vertically upwards at a speed of this. Okay, and then what you do is you find out the time of flight. You find out the time of when you shoot a cannonball vertically upwards. You find out the time of flight. So when you fire this cannonball, it will travel from here to over here. But what you do, because the diagonal is really complicated to analyze, what you do is you visualize this, calculate how long it takes for the cannonball to travel like this, up here and then free fall back down to here. So calculate this bit here, the vertical component. So we are now firing the cannonball at this speed vertically upwards, and then calculate how long it takes for the cannonball to do this. You see, the time it takes to do this is the same time as it takes to do this. Okay, and once you've got your time of flight, then it's you sitting in your dad's car, and then you drive for that amount of time. So the question is, well, if you and your dad sitting in a car traveling at what was it, 80 cos 72 meters per second, and let's say you travel for 5 seconds. Well, then you just get this and times it by 5. Okay, well, 1, 2, 3, 4, yeah, so basically work out the time of flight, and then once you've got your time, then multiply it with the speed. That will give you the distance traveled. Okay, so let's try and do this here. So at the moment, break this diagonal thing up. Break up this diagonal thing. So hang on. So this here would be what was it? 80 sine 72. This here would be 80 cos what? Cos 72. And then immediately jump to your velocity time graph. So your velocity time graph. Hang on. So it will look like this. The initial. Remember, we are now just looking at this. We are just looking at the vertical component. Okay. Forget this for the time being. Forget it for the time being. Just work out how long it takes for the cannonball to do this. Maximum height, and then free fall back down to here. This time here represents the time of flight for this thing here. Okay, so hang on. So we are trying to find out the time of flight, Now the initial velocity. Remember, we are firing the cannonball vertically upwards. Okay, so the initial velocity will be 80 sine 72. Okay, we are trying to find. Yeah, we are trying to find out the total flight time. But first, find out the time it takes to get to maximum height. Because this point here is really important. Once you've got this point, then well, I'll tell you later. Okay, so here you've got your next step, find the equation for this line. Well, this line, well, any straight line is y equals mx plus c. Okay, the gradient happens to be minus 10 because we're on Earth. Gravity on Earth is 9.8, but we're going to round it off to 10. So minus 10x plus c. Well, the intercept is this bit here. So that's the intercept here. So that's 80 sine 72. So well, let's tidy up now. So the velocity equals, the equation for this line here is v equals 80 sine 72 minus 10t. Okay, so this is your magical equation for this line. Now we want to find out t max. Well, at t max the velocity is 0. So let's put 0 into this v. So 0 equals 80 sine 72 minus 10t. Now try and work out t now. So t equals 80. Well, I'm jumping the gun here. Hang on. Over 10. Okay. So let's just merge these two together. So that becomes 8 sine 72. So the time it takes to get to maximum height here, t max equals 8 sine 72. Okay, so that's a time. If you really want to know the number in real time, then okay, let's find out. The time it takes to get to maximum height would be sine 72. So hang on, 72 sine, where's sine? Sine here, and then times 8 times 8 equals this. So it takes 7.6 seconds to get to its maximum height. But let's just leave it as this here. Okay, so this is the time it takes to get to the maximum height. Now the total flight time would be well, the time it takes to get to maximum height is this. The total flight time would be times 2 basically. Okay, so t max times 2, because the time it takes to get from here to here is the same as the time it takes to get from maximum height down to the ground. Okay, so look at this here. This is t max here. So well, at the moment t max is 8 times sine 72. Remember, sine 72 is just a number. So this thing here at the moment is really just 8 times this number. Okay. Now when you come to times 2, because you're trying to find out the whole total flight time. So when you come to times 2, you're just basically timesing 2. So now let's merge the two numbers together. So hang on. So total flight time. So let's call it flight. Okay, flight time equals well, let's merge these two together, because in effect we are just getting this times 2. And when you times 2, let's just merge these two together. So 16 sine 72. Okay, so that's the total flight time. So let's just imagine it takes let's just say 5 seconds. Okay, now imagine you and your dad sitting in a car traveling at a speed of 80 sine 72. It's underneath here. It's getting a bit messy. But now imagine your dad is traveling at this speed here, and then now that you know it takes 5 seconds. Well, remember, I'm just pretending to be 5 at the moment for simplicity. Let's say it takes 5 seconds to get from here to here, and then you would just get 5 times the speed to give you the distance. Okay. So basically, now that we've got the flight time here. Okay. Now imagine. So hang on. So let's just do this here. Remember, hang on, it's going to travel like this. Our vertical component, well, we've dealt with that. Now let's look at the horizontal component, 80 cos 72. So now imagine you and your dad sitting in a car traveling at a speed of 80 cos 72. So this is your speed, meters per second here. Well, if the flight time is this, okay, if the flight time is this, then you would just get the flight time times the speed to give you the whole range, okay? Because hang on, let's imagine your dad is doing 3 meters per second, and you know that the flight time is, let's say, 5 seconds. Then, well, after 1 second, your dad would have done 3 meters. After another second, he would have done another 3 meters. After another 3 seconds, well, after another second, it will be another 3 meters. So basically, it's just this times this. Now, we've got our flight time here, which is this. So it's just basically this times the speed. That will give you the distance. Okay. Well, once you've got your flight time times then imagine you sitting in your dad in your dad's car and driving it at a speed of this. So you would get this times it by this. So the range, but by the way, the whole distance here is called the range. Okay, the range of the cannon would be range equals what was it? Flight times horizontal speed. Okay, horizontal times by the horizontal speed. So the flight time is this thing here, 16 sine 72. So flight time is 16 times, what was it, sine 72, and the horizontal speed is 80 cos 72. Okay, so times 80 cos 72. Remember that this here is just a number multiplying with this number, and they're all multiplying each other. So you can imagine it as this. Okay, equals. Well, you can imagine it as this. 16 times sine 72 times 80 times cos 72. Let's merge these two together. So what's that? Calculator, clear. What was it? 80 times 16 equals this. 1280 was it? Yeah. And then now this times this. So it's just sine 72 cos 72. So at the moment it's this times this times this. So that will give you the range. But this is useless. So let's turn it into a number, and then hopefully we can answer our question. If your enemy is standing 500 meters away, would you be able to hit that person? So clear this. So let's work out cos 72. Well, it doesn't matter how you do this. Just do it. Cos this. This is going to be ugly. I hate this calculator. Hang on. So cos 72 is 0.31. Okay. And then let's do sine 72. Clear this. Sine 72. Where is it? Sine. Yeah. Sine equals this. Hang on. Let me double check. 72 sine, where is it? Sine is this 0.95, and then all these three numbers multiplying together. Okay, so this equals, hang on, calculator. So this times, because I'm not used to this calculator, I don't really like this calculator, equals this, and then times 1280 equals this. So the range is 377. Okay, 377. So what that means is our range is hang on, clear this. So our range is 377 meters away. So what's happening is that if our enemy is 500 meters away, our cannonball really it lands somewhere around here, just 377 meters away. So the answer is no. We didn't kill anyone. Okay.